in today's note, we're going to be looking at slope and rate of change. So slope, or in other words, rate of change, they both mean the same thing, is a measure of the steepness of a line. And our formula for slope, we should remember slope equals rise over run, or rise divided by run. And it could also have an algebraic formula, which is y2 minus y1 over x2 minus x1. So all our examples we're going to be looking at determining the slope of a line. So in A, I have y equals 2x plus 1, and I want to determine what is my slope. So in order to do this, I need to create a table of values. So for my x values, because x represents the independent variable, I get to pick whatever values I want for x. So I'm going to use -2, -1, 0, 1, and 2, just to make it a little bit easier. Again, you can pick whatever values you want. To figure out the y value, I need to substitute this x value into my equation. So that means wherever I see the x, I need to replace it with whatever my first x value is going to be. So in this case, my first x value is -2. So in my equation, I have y equals 2 times -2 plus 1. All I've done is replace the x, and I'm just going to go through and solve. -2 times 2 is -4 plus 1. I get y equals 3. So I'm going to move these down. And I'm going to go through the same process with my next x value in -1. So y equals 2 times -1 plus 1. Y equals -2 plus 1, which equals -1. Move these down a bit. So, and I can go through and do the exact same step with all the other x values. So I should get 1, 3, and 5. Now that I've completed my table of values, what I can do is I can go through and plot these points on a graph. Again, remember, a point on a graph is a coordinate of x and y. X tells us the horizontal, y tells us the vertical. So I'm going to plot all of my points. So I have -2, -3, -1 and 1, 0 and 1, 1 and 3, 2 and 5. Once I have these points plotted, I can draw a straight line through them. And there is my line. Now that I have my line, I need to figure out my slope, or rise over run. I'm going to pick any 2 points on the line. I'm going to, for easiness, I'm going to pick my first point and my last point, and I want to figure out how far over do I have to go and how far up do I have to go. Remember, rise is up or down, run is left or right. So in this case, I'm going to go 1, 2, 3, 4 units to the right. So that means my run is going to be 4, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 units up, so plus 8. So that means that my slope, or rise over run, is 8 over 4. This I can reduce, 8 over 4 I can reduce to 2 or 2 over 1. So that's my slope. In example B, I'm going to do the exact same thing. I have my equation, I need to come up with a table of values. So I'm going to use -2, -1, 0, 1, 2. At -2, again, to figure out the y value, I'm going to substitute it into the equation and solve. So -2 means it's +2 minus 5, which means -3. When x is -1, I get positive, so this is -4. 0, -5, -6, and -7. Now that I have these points, I can go through and plot these points on a graph. So at -2, I'm at -3, -4, -5, -6, -7. With those points now, I'm going to connect them with a straight line as best as I can. And now I have my equation, or my line drawn. To figure out the slope, again, remember, because slope is rise over run, I need to find 2 points on my line. Again, it doesn't matter which 2 points you use as long as you pick 2 points. So I'm just going to use these 2 points. And again, my rise, I'm going to go down 2. So -2 is my rise because I'm going down. And I'm going 2 in the positive direction. So that means it's +2. And if I want to simplify this, it becomes -1. Again, it doesn't matter which 2 points you use, and it doesn't matter which direction you go. Because if I go from the bottom point left, that means the run would be negative, but then I go up, which means the rise would be positive. Either way, I still end up with the same answer. So it doesn't matter which ones you go through, as long as you're going in the same direction from one point to another. For C, I'm going to be doing, again, the exact same thing. I'm going to pick out x values. I'm going to pick different values only because I know what the slope is going to be already. So I'm just making it a little bit easier on myself. But again, you can pick whatever values you want. Once I know these values, I need to substitute them into my equation for x. And then I'm solving for what my y value is. So 1/2 times 4 divided, or minus 3. 1/2 times 4 is 2 minus 3, which equals -1. I'm going to do the same thing with 2. When I plug 2 in, I should get y equals negative. No, I get, so I get 1/2 times 2 minus 3. So I get 1 minus 3, which is -2. Oh, sorry. My mistake. These should be negatives. So -4 minus 3 is -5. So it's alright, just changing some of these up a little bit. -4. There we go. 0, I would have -3. At 2, I'd have -2. And at 4, I'd have -1. So when I go through and I plot these points, -4, -5, -2, -4, 0, -3, 2, -2, 4, -1. And again, I'm going to connect these points with a straight line as best as I can. And I'm going to figure out my rise over run from one point to the next. So again, it doesn't matter which 2 points you use. I'm going to use the bottom point and the top point. So here my rise is 1, 2, 3, 4. So +4. I'm going in the positive direction as well for my run. So we go over 1, 2, 3, 4, 5, 6, 7, 8. Go over 8, so 1/2. Right? 4/8 can be reduced to 1/2 or 0.5, either way. Again, one key thing, it doesn't matter which points you use, but it does matter what things you count, right? In every example, we've been counting the squares. 1 square, 2 squares, 3 squares, 4 squares, right? But we have to make sure that the scale that we're looking at is also going up by 1 if we're counting the squares. In this case, the scales are going up by 1, so that means that each square represents 1 unit. If the scales on the y-axis or the x-axis were different, then I'd have to be careful with counting the squares. And we'll see an example in later notes of what I mean by that. But again, the key thing from this is just being able to determine the slope using rise over run.